There is a house hidden beneath the earth, and inside it feels calm and cool, even in the middle of the desert. Above it, there is only rock, dust, heat, and emptiness. But below that barren land lies comfort. From a distance, you would never notice it. Up close, it feels like the earth itself has opened a door. In a place where 100-degree heat overwhelms people, this house does not fight the heat at all. Because this house does not resist the climate, it simply lives outside the climate's reach. What is blazing hot above ground becomes distant and muted below the surface. Stone walls, deep shadows, and warm interior light. This is not just a house, it is a quiet rebellion against climate. Where everything above ground is exposed, the power of this house comes from remaining unseen. At sunset, the desert cools slowly, but underground, this home has stayed almost the same all day. So the question is simple. If this idea is so smart, why is it still so rare? This story is not new. 1,000 years ago, people in the Utah desert were already building homes like this. They did not know the words thermal mass or insulation value, but they understood what Earth could do. A small fire, a low roof, and walls pressed against the ground. This was enough to survive winter. Outside, frost. Inside, sleeping children. The walls were not cold because the walls were not facing the air. These were not experiments, they were settlements, families, generations, and a practical way of life. Even now, traces of those pit houses remain in the earth, proving that people once lived with climate instead of against it. And it was not only in North America. The same idea appeared again and again across the world. Earth, stone, wood, and fire, these were the materials of climate-smart architecture long before modern engineering. Under star-filled skies, underground shelter gave people one of their first stable indoor climates. This is not a forgotten fantasy. It is knowledge modern civilization simply stopped paying attention to. In Iran, families carved homes into soft mountain rock, and in winter, many still return to them. These cave dwellings are not just history. In some places, they are still part of living reality. Low ceilings, stone walls, dim light, and quiet warmth. Inside, the outside weather feels very far away. When an entire hillside becomes a place to live, it is no longer a curiosity. It is a proven system. In Tunisia, people went even further. Instead of carving into slopes, they dug down into the earth. Above them was a burning sun. Below was a shaded courtyard where heat could not easily follow. These underground courtyard homes show that geography may change, but intelligent shelter follows the same logic. From above, they look like circular cuts in the ground. From inside, they reveal a complete architectural system. In Matera, Italy, cave homes carved into stone sheltered people for centuries upon centuries. The generations changed, the stone remained, and the houses kept doing their job. Soft light inside, ancient weathered rock outside. This kind of architecture survives both time and climate. Utah, Iran, Tunisia, Italy, 4 regions, one repeated solution. It is as if human civilization left scattered notes across the world, all pointing to the same answer. Earth, plaster, stone, carved walls, different materials, same goal, more comfort with less energy. These civilizations did not copy one another. They arrived at the same solution because the physics never changed. What ancient people understood by instinct was later measured by modern science. And when the data finally appeared, it showed that the old builders were not wrong. A conventional house constantly battles outdoor temperature, trying to stay cooled in summer and warm in winter. An earth-sheltered house avoids much of that battle because the ground changes temperature slowly. One structure is exposed to every swing in the weather. The other is buffered by the planet itself. 10 feet below the surface, soil temperature stays far more stable throughout the year. The Earth does not work like fiberglass alone. It absorbs heat, stores it, and releases it slowly. In winter, that means sudden colds does not easily invade the living space. In summer, that means brutal surface heat does not immediately turn the interior into an oven. In a real sense, the ground acts like a thermal battery, silent, massive, and always present. Studies and simulations have shown that this kind of design can reduce energy use dramatically. In some climates, the savings are not minor, they are large enough to make normal construction look inefficient. Imagine a house where comfort requires less machinery, less effort, and less energy every day. There is no magic here. The house simply starts closer to a comfortable temperature. That is why this ancient technique is not obsolete. It is still measurable, testable, and improvable today. So if the physics works, why do we almost never build this way? Because the real obstacle is often not science, it's paperwork. Modern building codes were mostly written for houses that face the sky, not for houses buried in the earth. If a bedroom sits deep underground, a normal window is no longer enough for emergency escape. Now, the design needs shafts, ladders, clearance rules, and engineered solutions. Then come the applications, the exceptions, and the burden of proving that this unfamiliar design is still safe. Natural light requirements make another problem because they assume walls are exposed to open air. So the code may not say no directly, but it can make yes expensive, technical, and difficult. Zoning rules and suburban lot design create more friction for homes that do not present a normal street-facing facade. Then the appraiser arrives and asks the next impossible question: what is this house worth? Banks don't like unfamiliar things, and unfamiliar homes often get treated as risky homes. That means more delay, more explanation, and sometimes no financing at all. It's easy to price a house when 3 similar ones sold nearby, but what if there are no similar homes? That's how innovation gets slowed, not always by a ban, but by 100 small barriers. The problem is not that the house fails, the problem is that the system was never built to recognize it. Conventional housing supports an entire economy of furnaces, air conditioners, ducts, filters, maintenance, and replacement. That system assumes the house will always be fighting the climate. And where there's constant energy use, there are bills, service contracts, and steady revenue. But the more passively comfortable a buried home becomes, the less it depends on that entire system. It doesn't generate the same monthly demand for equipment, repair, or energy consumption. So it doesn't have to be banned to be ignored. It only has to remain outside the normal template. Most people simply follow the path that banks understand, builders know, and code officials review easily. This may not be a conspiracy, but inertia can be just as powerful. A house that works with the climate now appears strange only because the standard house became normal. And that may be the reversal. The underground house is not the anomaly, the exposed box might be. Still, there are places in the world where people never abandoned this logic. In the Australian outback, many residents turned to the earth because the surface climate was simply too extreme. There, underground living is not a novelty, it is a practical response to reality. Homes, churches, hotels, and public spaces can all exist below ground when the heat above becomes too expensive. Above the surface, the town looks harsh and unforgiving. Below it, life becomes quieter and more stable. In Iran, too, families still return to rock-carved winter dwellings because the old solution still works. As modern architects search for resilient design, these ancient structures are becoming relevant again. Case studies, built examples, and historical settlements all point to the same conclusion: this is not just theory. In fact, with modern materials and design language, buried homes can become even more refined and livable. So the problem is not lack of proof, the problem is lack of adoption. But this story is not perfect. The greatest enemy of an earth-sheltered home is not heat, it is water. Because if a buried wall leaks, the damage may remain hidden far longer than in a normal house. A bad membrane, poor drainage, or careless backfill can turn a small mistake into a major failure. When rain falls, the surrounding soil can hold water against the structure with relentless pressure. That's why waterproofing here is not optional. It is central to whether the entire system works. Membranes, rigid insulation, drainage layers, and perimeter drains all have to perform together. A roof leak may reveal itself with a stain. A buried leak may stay invisible until the damage is severe. That's why this kind of house cannot be built carelessly. It demands serious detailing. Sometimes it also needs discrete mechanical ventilation to meet both comfort and code requirements. So yes, the idea is real, but the execution has to be precise. And still, one truth remains. The ground beneath your home is already holding steady temperature every day. Almost every piece of land sits above a quiet climate system that most modern design ignores. Ancient people discovered that through instinct. We are rediscovering it through measurement. Perhaps the smartest homes of the future will depend less on machines and more on geography. Because in the end, the Earth is not just a foundation. Used wisely, it can become the house itself.